Hello, today we will discuss about electric dipole in a uniform external electric field. So here in this diagram, AB is an electric dipole having equal and opposite charge minus Q and plus Q separated by a short distance 2A. Now, as we know, when any charge is put in electric field, it will experience a force. And any charge, as we know, E equal to F upon Q. So F equal to QE. So when any charge, when it is placed in an electric field, it will experience a force. So in the same way, this charge plus Q, this will experience a force. This will experience a force F1. This F1 is equal to Q times E. Similarly, the negative charge, here is a negative charge, it will experience a force F2. And this F2 will be opposite to the direction of electric field. So F2 is equal to minus Q times E. So these are the two forces acting on this electric dipole. So the net force on this dipole, F net is equal to F1 plus F2. So it is minus QE plus QE. F1 is plus QE while it is minus QE. So it is QE minus QE, that is equal to 0. So F net force on the dipole is 0. So it is in translatory equilibrium. So this implies that no translatory motion. Now the next thing, the line of action of these two forces. जो F1 फोर्स है, F1 फोर्स, इसका लाइन ऑफ एक्शन ये राइट की तरफ है, लेफ्ट टू राइट at the point B, and the line of action of F2 is towards left at point A. So the line of action of these two forces F1 and F2 are not same. So they will make a couple and they tends to rotate the dipole. Means there will be a torque on the dipole because these are the two forces which are equal and opposite. So torque is equal to either force multiplied by perpendicular distance between their line of action. So the torque, it is represented by a vector, it is represented by a symbol tau. Tau is equal to either force is QE into multiplied by perpendicular distance. Here perpendicular distance is BC. जो दो forces हैं F1 और F2, इनके बीच का जो perpendicular distance है वो BC के equal है. So QE into BC, and this BC from this triangle ABC, here it is theta, AB is 2A, so this BC will be equal to 2A, BC will be equal to 2A sin theta. BC will be equal to 2A sin theta, so QE into 2a sin theta. So q into 2a into e sin theta. So here q into 2a, this is equal to dipole moment p, so it becomes pe sin theta. So tau is equal to pe sin theta. Here theta is the angle. Theta is the angle between p vector and e vector. This is the point to be noted, that theta is the angle between p vector and e vector. So we can write this in the vector form. Tau vector is equal to p cross e. Because torque is a vector, so it has a direction. It is a vector, so there will be direction, and direction will be given by right hand thumb rule. If we curl our finger, here p vector is in this direction and e vector is in this direction. And here is the angle theta. So when we curl our finger of right hand from P to E, the thumb will point into the page. So the direction of this tau will be perpendicular to the plane containing P and E and points inward. तो इसकी डायरेक्शन अंदर की तरफ होगी, because it is a vector quantity, and the unit, the important thing is unit of tau because it is a force into perpendicular distance. Tau is a force into perpendicular distance. Force, the unit is Newton, and for distance it is meter. So SI unit of tau is Newton meter. Now there are some points related to this torque. Number 1, note number 1, when theta is equal to 0. इस डायग्राम में ये जो थीटा एंगल है, ये थीटा एंगल अगर 0 है, then when theta is equal to 0, so according to the formula, tau will be equal to Pe sin theta. Pe sin theta means it is 0. So tau equal to 0, and in this case P and E are parallel. P and E are parallel, and the dipole is in the position of stable equilibrium. Now the second point, when theta is equal to 180 degree. Again, the tau, that is torque will be equal to 0, and in this case P and E are anti-parallel. In this case these two are anti-parallel, and the dipole is said to be in unstable equilibrium. Third point, when theta equal to 90 degree, theta is equal to 90 degree, so this tau will be maximum. Tau is maximum, and from the formula, the tau max is equal to PE sine 90, that is equal to PE. So tau maximum is equal to PE. So torque is a vector quantity, and the direction is given by right hand thumb rule, because it is the product of this tau. Tau is the product of P vector and E vector. So these are the three cases. When theta equal to 0, torque will be 0, P and E are parallel, and the dipole is said to be in stable equilibrium. Number 2, when theta is equal to 180 degree, in this case also, by the formula tau equal to 0, and the case when P and E are anti-parallel, in this case the angle is 180 degree, and the dipole is said to be an unstable equilibrium. The third case is when theta equal to 90, tau will be maximum, so tau maximum is equal to PE sin theta.